Giving an autonomous AI agent the ability to execute tasks requires trust, but giving unpredictable logic free rein over your host machine is a security risk. NemoClaw solves this by placing the agent inside an impenetrable box. NemoClaw is currently an alpha release, built for early experimentation rather than production environments. It uses the OpenShell runtime to lock down the Nemetron AI model, ensuring that the agent remains strictly contained. Before we start the installation, you must have 3 things running on your system: a fresh installation of openclaw, an active instance of Docker, which is a platform for building and running containers, and a machine running Ubuntu 22.04 or later. This chart shows the system memory load during the Docker image push. The export pipeline and the OpenShell gateway run simultaneously, buffering decompressed layers directly in your memory. If your machine has less than 8 gigabytes of RAM, this combined usage will trigger an OOM, or out-of-memory, killer, crashing your system. To prevent this, you must configure at least 8 gigabytes of swap space. By strictly meeting these hardware and software baselines, you guarantee your host system remains stable and protected, even as the AI inside the sandbox executes unpredictable commands. Step 1 is acquiring your API key. Navigate to build.nvidia.com and generate a new key for your account. Keep this key handy, as you will need it during the setup. This diagram shows how requests are handled. When the agent attempts to think, the sandbox prevents it from making a direct connection to the internet. Instead, the OpenShell barrier intercepts every inference call and safely redirects the path. That path routes securely to the NVIDIA cloud. Your API key authenticates this connection, allowing the external node to process the heavy lifting, while the agent stays completely isolated. Open your host terminal and execute the NemoClaw installation script using curl. If your system is missing Node.js, a cross-platform JavaScript runtime environment, the script detects this and automatically installs it. Next, the script launches an interactive onboard wizard. When the wizard prompts you to configure your inference provider, paste the API key you generated earlier. The script then applies the baseline security policies and provisions the sandbox environment. This automated setup builds an architectural one-way mirror. The AI functions as if it is operating locally, but its cognitive processing is strictly controlled and offloaded to the cloud. This terminal window shows the specific summary box you will see when the installation script finishes successfully. Read the structured tabular section to confirm that your sandbox, named My Assistant, is active, and that your inference traffic is properly linked to the Nemetron model. To bridge the gap and enter this new environment, run the command NemoClaw My Assistant Connect in your terminal. Notice how your terminal prompt changes. This shift indicates that you have crossed over from your host machine into the isolated container. This diagram illustrates the strict difference in command hierarchy. You use NemoClaw commands out here on the host machine to manage the environment, but you only use openclaw commands once you are inside the sandbox. Inside the container, a baseline file system policy is actively protecting your host. It restricts the agent entirely to the sandbox and temp directories, blocking all other read or write access. Crossing this terminal threshold means you've moved from a general-purpose computer into a highly controlled domain, where every AI action is governed by declarative policy. To initiate your first chat, type openclaw TUI from within the sandbox. This launches the terminal user interface, an interactive chat environment built directly into your command line. Type a short test message and press enter. You will see the agent's response generate live on your screen, verifying that the inference routing is functioning correctly. Alternatively, you can use the openclaw command line interface, or CLI. This allows you to send a single message and print the response, which is highly useful for automated scripting instead of conversational chat. If the agent attempts to reach an unlisted host, OpenShell immediately blocks the unauthorized network connection. It then surfaces that request in the TUI, waiting for your explicit operator approval before proceeding. Successfully chatting with the agent proves you now have an active, responsive intelligence that is completely physically contained. Your baseline deployment of the NemoClaw secure environment is now fully operational. From here, you can explore blueprints. Blueprints are versioned Python artifacts that allow you to customize specific network and file policies for your agent. These policies feature a hot reload capability. You can dynamically update network egress rules on the fly without needing to reboot the entire sandbox. Advanced users should review the official documentation for experimental features, such as using the NemoClaw deploy command to push the environment to a remote GPU instance through Brev. While this software is in early-stage development, mastering this blueprint orchestration gives developers the foundational framework required to deploy production-ready autonomous AI safely.